Okay, so we're given that AB is congruent to DC and AD is congruent to BC, and we want to prove that ABCD is a parallelogram. So one thing I always recommend is writing the first and last lines of your proof, okay, and then trying to fill in the details, okay. So the last line of our proof we know should be that, right, A, B, C, D is a parallelogram. And for all these proofs that you're going to do, that should be the last line, right? Because that's what we're proving. But now let's think about what we need to show to do that. So right now, all we know, okay, the only thing we have to work with is the definition of a parallelogram, okay? So it's a parallelogram if we can show that, okay, AD is parallel to BC, and that AB is parallel to DC, right? That's our definition of a parallelogram, okay? So that's the only thing that we have in our toolkit right now to be able to claim that something is a parallelogram is that definition, okay? And so that should actually be, okay, so we have to show each of these things, okay? We have to show that those two pieces are parallel, and once we've established that, then we can say that ABCD is a parallelogram, okay? So let's see where we can start here. Okay, so the hint is to construct a diagonal, and it doesn't matter which diagonal you construct. Okay, so I've constructed DB as a diagonal, and so if I want to show that those two lines are parallel, I have to think back to what I know about proving things parallel. So when you wanted to prove lines parallel, we could show that alternate interior angles were congruent, right? Alternate exterior angles are congruent, or same side interior angles were supplementary. Any of those things would allow us to conclude that the lines were parallel. So now that I've drawn this diagonal, hopefully you see that, hey, maybe if we can show, okay, that these alternate interior angles are congruent, okay, then we conclude that the lines are parallel, right? And we could also show that these two are congruent, which would allow us to show that A, B, and DC are parallel. So we want to try to show that. Now we haven't shown that yet, so I'm going to not put those on there. But I think if we can now show that those triangles are congruent to each other, we can show that. So let's first set about proving that the triangles are congruent. Okay, so for my next step, C is congruent to, DB. DB is congruent to segment DB, right? Or BD. And that's by the reflexive property. And so now I'll come up here and I'll mark this is congruent with itself. And so now I can say that that triangle A, B, D is congruent to triangle C, D, B. And that's by side, side, side. So now, if those two triangles are congruent, I can now I can talk about this angle here, okay, which is BDC, I can say that that's congruent to that angle, since those are corresponding parts of congruent triangles, okay. And so if it's helpful, actually what I'm going to do here, guys, is I'm going to name these. I'm going to write 1, 2, 3, and 4. Okay, just to make the labeling these a little bit easier. So now I can say, okay, well, in my next step, I'll say that angle 2 is congruent to angle 4. Okay, and that's by corresponding parts of congruent triangles are congruent. And I can make a similar argument that angle 1 must be congruent to angle 3 by the same reason. Okay. And so I'll mark those as congruent. All right. And now, note that, okay, angle 2 and angle 4 are alternate interior angles of lines AB and DC. Okay. So here I can say that I can say that AB is parallel to DC because the alternate interior angles are congruent. Okay. And really we would say, because, two lines that are cut by a transversal, if their alternate interior angles are congruent, then they are parallel, right? We're just going to shorten it to this. And I can make the similar argument to say that because angles 1 and angles 3 are congruent, they form alternate interior angles for AD and BC. So AD is parallel to BC. And again, alternate interior angles are congruent. Okay. And note that is what I was trying to show. Okay. So if I show that, then it follows that, okay, I can jump straight to this conclusion, because this is what is necessary. This is the definition of parallelogram, right? That those opposite sides are congruent. So I can conclude that ABCD is a parallelogram by definition of parallelogram. And that completes my proof. So now that we've proved this, you can use this result to prove any of the following items, okay, if that's necessary. So now we have two ways of showing that something is a parallelogram. We can either show that the opposite sides are parallel, okay, or we can now show, since we've proven this, we can now show, if we can show the opposite sides are congruent, you can conclude it is a parallelogram, okay. So that's the example of that proof. In your groups, you guys will talk about the next several proofs, okay? And X Day is only half an hour long, okay? But at least start getting some thoughts together, maybe definitely you've got the first line, make sure you've got the last line, see if you're either going to try to show that lines are opposite sides are parallel or show that opposite sides are congruent, okay? And then we'll spend some class time on Thursday working through the rest of that, all right?